This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to take a look at the slope of parallel and perpendicular lines. Well, as you remember, As you remember, in the previous video we talked about perpendicular lines, and we took two perpendicular lines and proved that the slope of each of these lines is equal to the negative reciprocal of the slope of the other one. And so that basically means that if two lines are perpendicular, their slopes are basically the slope of each of those lines is equal to the negative reciprocal of the other line. Or if you take the slope of each of those lines and multiply them together, for example, let's say you have a line over here like this. You have a line here like this. Let's say you have this line over here and also this line over here, and these are, let's say these are perpendicular. Then this line has slope m1 and this line has slope m2. So in this case these two lines have if you just multiply m1 into m2, you're going to get 1, and so that basically means that m1 is equal to minus 1 divided by m2, and also m2 is equal to minus 1 divided by m1. Now if you have two lines that are parallel, for example, let's say you have a line over here and you have another line over here. Now these two lines are parallel. Let's say these two lines are parallel, and this one has a slope m1. This one has a slope m2. Then in this case m1 is basically equal to m2. So now if you consider these two lines in a Cartesian coordinate system, let's say this is a Cartesian coordinate system. Let me erase this, and let's say this is your x-axis and this is your y-axis. So you can see that these two lines, and here m1 is equal to m2. So these two lines are parallel, and as you can see they have the exact same slopes. The only difference is that they have different y-intercepts. This line cuts the y-axis on a different point than this one. But it doesn't have to be necessarily this way. For example, you could have your line like this. For example, you have a line like this, something like this, and then you have another line something like this. And then again these two lines have let's say this one has a slope m3 and this one has a slope m4, for example. And so here again m4 is equal to m3, and the only difference here that you can see is that they have different y-intercepts. This one cuts the y-axis at this point, and then this one cuts the y-axis at this point, and these 2 points are clearly different. So that is all about the parallel lines. So all you need to know about parallel lines is that parallel lines have the same slopes, perpendicular lines have slopes that are the negative reciprocal of each other. That's all you need to know here. And so now let's do an example on this to understand this better. 28. What's going on in here? So cancel. My 28-1. So, okay. So then we have basically example number 14, graphing two equations and determining whether the lines are parallel, perpendicular, or neither. So graph the equations of the given lines and state whether they're parallel, perpendicular, or neither. Now the equations are basically 3y is equal to 3y is equal to minus 4x plus 3, and the other equation is 3x minus 4y is equal to 8. Now if you want to graph these equations, basically all you need to do is you could do that the method that we did before. For example, form a table over here, and let's say for example here you write some x values, some y values, and you find some ordered pairs over here, for example related to this first one, and then you can plot those ordered pairs in a Cartesian coordinate system and just join the lines, join the points together and draw the lines. I mean essentially draw the graph. But there is an easier way if that works, and that is you could kind of go through try to simplify this equation, any of these equations, and see if you can find some clues in the equation itself so that you don't have to plug in all of those values. For example, in case of this first one, you can write this as, this is basically 3y is equal to minus 4x plus 3. Now if you want to, you can write this in the slope intercept form, and the slope intercept form is basically y is equal to mx plus b. If you write this equation in this form, you basically know what the slope is, and you also know where it crosses the y-axis, and based off of these 2 points, you can simply draw the graph of the function, but probably not the exact actual function. But here what we want to do is not basically draw the function of the graph. Here we just want to check if the graph of the functions are perpendicular or parallel or neither. So then if you have even a vague idea of the shape of the graph, then you can decide whether the two functions are perpendicular or not, or neither, or whatever. So now let's do this. I want to basically, this is 3y is equal to minus 4x plus 3. So what I can do here is divide everything by 3, so, or multiply both sides of this equation by 1/3. So 1/3 into 3y is equal to 1/3 minus 4x plus 3. Now 1/3 into 3y is equal to y, and 1/3 into minus 4x is equal to minus 4 by 3x, plus 1/3 into 3 is equal to 1. So now this equation is in the slope intercept form. Now you know that the slope of this line is minus 4 by 3, and you know that the y-intercept of this line is plus 1. So then let's do the second one. The second one is basically 3x minus 4y is equal to 8. You want to write it in the form y is equal to mx plus b. So keep your y term on this side and then take this one to the other side. So basically minus 4y is equal to minus 3x plus 8. Minus 4y is equal to minus 3x. This goes to the other side, becomes minus 3, and this is plus 8. So then you can multiply both sides of this equation into minus 1 divided by 4. So minus 1 divided by 4 into minus 4y is equal to minus 1 divided by 4 into minus 3x plus 8. So minus into minus is plus. 1/4 divided by into 4 is equal to 1, and so you're left with y. So y is equal to minus into minus plus is 3 divided by 4 x minus into plus is minus, and then 8 divided by 4 is equal to 2. So this is the other equation we were looking for, and this is the one that we found first. So now you can see that here your m is equal to 3 by 4. Here your m is equal to minus 4 by 3. Now according to what we said before, if m1, let's call this m1, let's call this m2. Now if m1 is equal to if m1 into m2 is equal to minus 1, then the lines are perpendicular. So this is perpendicular. If m1 is equal to m2, then the lines are parallel. And if none of these is the case, then we would say neither. It's neither perpendicular nor parallel. So then now you can see that the two lines seem to be perpendicular, because if you write m1 into m2, you would get m1 is minus 4 by 3 into m2 is 3 by 4. So you can cancel this 4 with this 4 out, 3 with 3, and then you're left with minus 1. So they are perpendicular. So I know that they are perpendicular. Now, as far as drawing the functions is concerned, I could show you how to draw the functions, but I guess we don't have enough time to do it in this video. So I'll draw the function, draw the graph of these two functions in the next video. So thank you.